Now, again, I had some equation here that gives me a curve, although that curve is not describing a function. Instead, I have found a way to parameterize at time t, where should my moving point be visiting on the xy plane. And then if I highlight every place, every coordinate that the moving point has visited, I will get the picture of the curve that I'm interested in. And again, this is called a parametric equation. So one way I could write this is that x is a function of t. The formula for x is that x will be equal to the cosine of t. Y is also a function of t, so both my x and y are dependent variables. The formula for y is that y is the sine of 2 times t. And this will look different depending on exactly what graphing calculator you are using. Most graphing calculators will have a way to graph parametric equations where you might have to specify maybe this is x with a subscript of a 1 and a y with a subscript of a 1, just in case you have multiple plots available to you in your graphing calculator's parametric mode. In Desmos, it looks like what I've done here in the purple line, that I need to have an ordered pair, and inside the ordered pair, the x coordinate is the formula for what x is equal to based on the parameterization, right? So my x is equal to the cosine of t, and I've put that here as the first entry in my ordered pair. My y is equal to the sine of 2 times t, and that's the second entry in my ordered pair. And then Desmos will ask you what domain this is defined on, what are the acceptable values of t to make this parametric equation work. And I said start at t equals 0, go up to t equals some other number a, and it's the number a which is sort of moving around the plot there. Now, there are multiple different ways to parameterize the same equation. I was saying before that I can change the formulas for my x and my y. So I could say, what if I want my drawing here to go faster? So it's looking a little bit slow to my eyes. I'd like to see this move around faster. What can I do? Well, let me replace t with something else. So everywhere I see a t, I'll replace it with, let's say, 5 times t. And oh, we get some interesting shapes there. We'll get back to those in just a minute. Here, I have a different parameterization where my x of t is no longer cosine. My y of t is no longer sine of 2t. The formulas are going to be different. So this will be cosine of 5 times t for my x, and sine of 10 times t for my y. But notice that this spells out the same curve, just that it goes, oh, I need to change it here too, just that it goes faster. See, now we're cooking. So one thing to keep in mind is that parameterization is not unique. So why is it that this parameterization gives me the same curve in blue that I started this whole process with? Well, if I square my x, I'll get cosine squared of 5t. If I square my y, I'll get sine squared of 10t, but that's the same thing as, say, twice sine of 5t times cosine of sine squared, excuse me, sine squared of 5t, cosine squared of 5t, right? Those are the squares of my x and my y. And if I divide that y by my x, well, what do I get? So that 2 will be canceled, that cosine squared will be canceled. And so no matter what value of t I pick, this formula is just going to be equal to 1. So this formula is still saying x squared plus y divided by 2x all squared equals 1. The very same equation still applies, even though I'm using a different parameterization. So here I just made my parameterization trace out the function faster, and it overlaps itself the further it goes.